Hey folks, welcome to the NCEA Level 2 Algebra paper from 2024. If you're joining us for the first time, the way this video works is that I go through each question and let you know what you need to do for achieved merit and excellence. The best way to do this, or watch this video, is to actually pause the video at the start of each question, try the question out by yourself, and then unpause the video just to see how I go about answering these questions. So without further ado, let's get started. Alright, so with question 1, what we've got is we've got to complete the square for this one. So basically what that means is we're going to have x squared plus 8x. And I'm just going to separate this minus 5 a little bit separate here. And I'll show you why we're going to do that. So basically what we're going to do is we are going to take the 8 and we're going to divide it by 2, which means we're going to get 4. And then if we do 4 squared, we get 16. So basically all I've done here is I've taken the 8 divided by 2, which gives me 4. And then I've taken 4 squared, which equals to 16. Now the reason why I want this particular 16 is I'm going to add 16 here. And I'm going to subtract 16 from the end as well. Basically, the green part and the blue part actually equals to 0, just on time. I haven't actually changed the equation in any way apart from putting a 16, but I'm also putting minus 16. Now the reason I want to do that is because then I can actually factorize this as simply as just x plus 4 squared, and then minus 5 and minus 16 becomes negative 21. So basically, that's pretty much all you need to do for this question to get an achieved. Now, say for example, you get this question and you kind of get stuck here. What you can do is you can actually go into the graph mode, because basically this is just a quadratic equation. So I'm going to plot it first. X squared plus 8x minus 5. When I draw this, I'm getting some sort of shape there. But what you can do is you can actually look for the vertex. So if I go, this is a positive one, so probably look for minimum here. And what you should see is negative 4 and negative 21. So if you remember the vertex form, you would actually have, if the vertex is negative 4 and negative 21, you would actually write this as x negative 4 squared minus 21, which is the same thing as saying x plus 4 squared minus 21, and that's what we're getting at the top there. So that's good enough for an achieved. We go to the next question. Right, so with this one we've been asked to find the discriminant of the quadratic equation, so we're going to rearrange this. So 3x squared, and that's going to become minus 5x plus 2 equals to 0. So we're going to find out b squared minus 4ac. So that is my a value. Got my b value, which is minus 5. And then c value is going to be positive 2. So I've got b squared, which is negative 5 squared, minus 4 times 3 times 2. So I've got 25, take away 24, and that's going to give me a discriminant of 1. And this question is also worth just an achieved. All right, going to question C. So we got this question where we need to write this as a single fraction. So what I'm going to do is I'm going to write this up with a little bit of space. So I've got 1 plus t minus 5 over t squared minus 1 over 3t. So basically from this point, what I'm going to do is I can see that I need a 3 in the denominator for everything. So that means I have got to multiply the denominator by 3 and the numerator by 3. Then also I need to make sure that I have a t squared in the denominator. So to do that, for the first fraction I'm going to multiply the denominator by t and the numerator by t. Second fraction I'm not really going to do anything. Third fraction I'm going to multiply by t in the numerator and denominator. So when I do this, in the first fraction I'm going to get 3t over 3t squared plus 3t bracket t minus 5 over 3t squared minus t over 3t squared. So putting this all together, I'm going to get 3t plus, I'm going to expand these brackets here, these two things, and I'm going to end up with 3t minus 15 minus t. Now remember, the denominator is 3t squared, so I'm going to put everything together as 3t squared. So I've got 3t plus 3t is 6t, minus t is going to be 5t, and I've got minus 15 divided by 3t squared. So grades wise, obtains the correct expression by putting two fractions over the same denominator and simplifying the numerator. Okay, so we've got to simplify the numerator and at least do two fractions, combining two fractions. So I'm guessing we're probably getting somewhere here for an achieved, and for a merit, this question is you need to do 5t minus 15 over 3t squared. Okay, so next question. So what we've got here is cubic polynomials given, blah, blah, blah. Graph of the polynomial has three roots, cuts the x-axis at -2, 1/3, and 4. Now, so it says use your knowledge of roots and find the values of constants, right? Now, if you remember in like the, I'm trying to think of, I think parabolas, right? So for example, in parabolas, when you have a solution, like let's say, I'm just going to do an example here just to show you. So if I have this parabola and I have x minus 2 times x minus 3 equals to 0, then I know that the roots are going to be +2 and +3. Now in this particular case, I have got -2, 1/3, and 4. So if I look at the first root, which is -2, then the bracket has to look like this, which is going to be x plus 2. Because remember, if I put x plus 2 equals to 0, I'm going to get x equals -2. And likewise, when there's a 4, I'm going to have x minus 4. Now, the most common mistake people do with the 1/3 is they actually write that as x minus 1/3. Now, I like to do it like this. I'm going to kind of show you this backward step just a little bit. Because, so imagine your root is 1/3. Now you got to cross multiply. You're going to get 3x is equal to 1, because I'm moving the 3 to the other side. Then I'm going to do 3x minus 1 equals to 0. So then my last bracket is going to be 3x minus 1. Now I should be able to actually expand the polynomial, because I've actually got 3x minus 1 multiplied by x plus 2 multiplied by x minus 4. And if I expand this bracket out, I should be able to get the values of a, b, and c. So I'm going to expand this bracket out. So I'm going to do the other one first. So 3x minus 1 multiplied by x squared minus 4 and 2 is going to become -2x. Minus 4 and 2 multiplied by each other, that's going to be, well, actually, no, I might actually do this the long method. So first, I've got x and x, which is x squared. Then I've got -4x. Then I've got 2x. And then finally, I've got -8. So I've got 3x minus 1 brackets x squared minus 2x minus 8. So now I've got to expand these brackets out. So I've got to do 3x times x squared. I've got to do all of those three things. 1, 2, 3. So it should be 6 terms altogether. So I've got 3x times x squared, which is 3x cubed. 3x times minus 2x is -6x. 3x times 6x squared. 3x times -8 is -24x. Then I've got minus 1x squared plus 2x plus 8. So I've got 3x cubed minus 7x squared minus 22x plus 8 equals to 0. And at this point, I can actually say that a is equal to -7, b is equal to -22, and c is equal to 8. And folks, pretty much for this question, identify the three correct factors is equal to achieved. So you got to get all three to get the achieved. And then finding ABC gets you a merit. All right, next question. Now coming to this question E, I know that last year there was quite a bit of people complaining about this particular question, but in reality it was actually a really nice question. So before we get started with this question, just remember this, and I think this is where people got stuck with. If you have a to the power of m times a to the power of n, then you actually add up the powers. And I think that's the key thing to remember in this particular question. So what I'm going to do is I am actually going to do the numerator first. No, actually no. Let's actually expand it out first. So I'm going to write this as x to the power of, let me just think. No, I'm going to write this as decimal points just because it makes it easier for me. Then I've got x to the power of 0.5. And then I've got x to the power of 0.5 minus x to the power of negative 0.5 divided by, I've got squared in the denominator, so I've got to write two of them. So I'm going to get x to the power of 1.5 minus x to the power of 0.5. And of course, I'm going to get x to the power of 1.5 minus x to the power of 0.5. Now, once we get this, what we have to do is we've actually got two quadratic equations, one in the numerator and one in the denominator. Now, I am going to go a bit slow with this one because it's like you just need to know what's happening in this question. So the first thing I'm going to do is I'm going to do FOIL, well, whichever one you want to do. So 1, then 2, 3, and 4. So if I look at the first one, x 1.5 and x 0.5, I've got to add the two powers. So basically what I'm doing here is I'm going to get x to the power of 2. Because remember, when you have two powers, two bases with different powers multiplying each other, you actually add the powers. So 1.5 and 0.5 is going to give me that 2. The next one I'm going to get is minus x to the power of 1. Now if you're wondering where I got that, I'm going to take the 1.5 minus 0.5, and that's going to give me negative x. Now I do the same for the bottom one. I'm going to get plus x to the power of 1. So this green one is actually from here. The blue one is 0.5 and 0.5. That's where I'm going to get x to the power of 1. Then finally minus x to the power of 0. Now for the 0, I'm looking at 0.5 and negative 0.5. That's going to give me 0. So that's pretty much the numerator. As for the denominator, I've got x 1.5 and 1.5. That's going to be x to the power of 3 minus x to the power of 1 minus x to the power of 1 plus x to the power of 1. Unless I've got this wrong, let me just double check that I've actually done this right. So sorry, no, I've not done that right. Just realized that. 1.5 and 0.5 is actually going to be 2. Sorry, these two values should be 2 there. Don't worry, I'll explain it to you very shortly. So basically, I've got 1.5 times 1.5 equals 3. 1.5 times 0.5 is going to be 2. And then I've got 0.5 times 1.5 is going to be 2. Looking for a different color. 0.5 and 0.5 is going to be 1. All right, so now let's put this all together. We've got negative x1 and x1, the middle terms. So basically this part here is going to become 0. So I'm only left with x squared minus x to the power of 0, which equals to 1, divided by x cubed minus 2x squared plus x. Okay, so now what I'm going to do is x squared, I'm going to write that as x minus 1, x plus 1, divided by, x is a common factor, I'm going to take it out. I'm going to get x squared minus 2x plus 1. Then I've got x minus 1 times x plus 1. And then I'm going to get x minus 1 and x minus 1. So at this point, I can cancel out 2x minus 1s. And I'm left with just x plus 1 divided by x times x minus 1. And that's the original proof that this question actually asked for. So correct expansion of either numerator or denominator is going to get you an achieved. Merit is factorization of either numerator or denominator factorization. I'm guessing somewhere here. And then excellence. So you get an E8 if you get all the way to the end. E7 if you make incorrect mathematical statements. So there we go. That's pretty much question 1 done. All right, folks. So for question 2a, I think what we've got to first do is get rid of the x first from the denominator. So we're going to bring it across, and we're going to have 3x minus 14, and we're going to multiply it by x to give us 5. Then we're going to expand these two brackets. So we're going to get, not brackets, expand the brackets, 3x squared minus 14x equals 5. Then we're going to get 3x squared minus 14x minus 5 equals to 0. Now we have been asked to solve for this. So from here you can actually use the quadratic formula, but if you do have the calculator, this just becomes a lot more easier for you, because all you do is go down to equation, polynomial degree 2, and you just need to punch in the values, which is 3, minus 14, and minus 5. So when we do this, we're going to get two answers. So x is equal to positive 5 or negative 1 over 3. Now, notice how this is the decimal point here, and the calculator does give it to you in a fraction, so keep that in mind. If you were to do this in the long method with just the quadratic formula, so I mean, you pretty much have minus b plus or minus b squared minus 4ac over 2a. You just got to substitute your b value, which happens to be minus 14, your a value, which happens to be 3, and then your c value, which happens to be minus 5. And then you can kind of do it that way. Of course, it's a long way. You know, having the calculator does make a huge difference, especially for these types of achieved questions. All right, so next one, we've got question 2b. When you get this question like this, you know, you've got square root of 9x squared plus 30x plus 25. The key thing to remember is, like, there is, you know, you've got to factorize this, right? So, and the kind of like the cheap way that I would do is, I mean, you can factorize it, right? Like, I mean, the way you would do it is you could actually go back to your calculator and just do the solver, equation and polynomial, and then you can punch in the values 9, 30, and 25. And when you do this, you actually, as you can see, you're getting two solutions, and your answer is actually negative 5 over 3. So if your solution is x equals to negative 5 over 3, cross multiplying it, you're going to get 3x equals negative 5. Rearrange it, you're going to get 3x plus 5 equals to 0. So basically, this numerator here could be written as 3x plus 5 squared. Okay. Now, with these simplification questions, and especially when you have a numerator over denominator, the one thing that I would recommend to you is have a look at the denominator, because obviously you're going to factorize the numerator, and then you've got to cancel one of the common factors out. So if you were to do that, hypothetically, if we were to just do the denominator plus 30x plus 25, in the denominator, you've only got x as a common factor. So if I take x out as a common factor, I'm going to get 5 plus 3x. Now, this is a clue that in the numerator, you're going to have 3x plus 5 in there as one of the factors. So now what I know is square root of 9x squared plus, well, that's just going to be 3x plus 5 squared, and then that's divided by x times 3x plus 5. Now when you take square root of a squared number, you're just going to be ending up with 3x plus 5 over x times 3x plus 5. Remember then, the numerator cancels with the denominator. Sorry, I forgot the bracket there. And this is then equal to 1 over x. So grades wise, factorizing the surd gets you an achieved. Factorizing the surd, now, I guess you get an achieved here, and then merit is all the way down here. All right, let's go to question C. Now with question C, what's happening is we've got find the value of k so that it has roots numerically equal but opposite signs, for example 2 and negative 2. Okay, right. So what we want to do is we're going to actually, and I guess I'm going to try and explain this, right? So imagine if you have like x squared minus 25 equals to 0, then you're going to get two solutions where you're going to get plus 5 and minus 5. So basically, when we rearrange this equation and make it into a quadratic, we want to make sure that middle the coefficient of x is equal to 0, because in x squared minus 25, because if you remember, this is 0x minus 25. Now I'm just using 25 here as an example, right? So let's go to the actual question. We've got x squared minus 2x divided by 4x minus 1 equals k minus 1, k plus 1. I'm going to cross multiply this, and I'm going to get k plus 1 multiplied by x squared minus 2x equals k minus 1 multiplied by 4x minus 1. Now what I have is a bunch of, FOIL, if you want to expand two brackets. Basically that's all I'm going to be doing with these sets of brackets. So I've got k times x squared, which is kx squared, then minus 2kx plus x squared minus 2x equals 4kx minus k minus 4x plus 1. So now I've got to bring all of these terms together. So I'm going to have kx squared plus x squared. Then I've got, just want to double check this, minus 2kx minus 2x, and then I want to bring in 4kx to the other side, because it's going to become minus 4kx plus k plus 4x minus 1, and all of this is equal to 0. So at this point I am going to collect all my x squareds. So I've got k plus 1 x squared, and then I'm going to collect all my x's. But before I do that, let's actually combine them. So I've got negative 2x and minus 4x, which equals to minus 6kx, and then negative 2x plus 4x is going to be plus 2x, and then I've got plus k minus 1. So I've got k plus 1 x squared, and then plus 2 minus 6k x. So basically I've taken x here as a common factor, and then I'm going to get plus k minus 1 equals to 0. So think about it like this, right? Now what we've got here is, see, remember we've got the x squared there. Then we've got the x value, which is right there. And then we've got the constant, which is this entire part. Now, if you want two solutions, then this coefficient of x needs to be 0. So in other words, 2 minus 6k should equal to 0. And when we put 2 minus 6k equals to 0, we're going to get negative 6k equals negative 2. K equals negative 2 over negative 6, and then we're going to get k is equal to 1/3. So we might just kind of say something like coefficient, and I think this is not given in the answer schedule, but I'm just going to write it anyway. Coefficient of x is equal to 0 for two equal but opposite sign answers or solutions. All right, so grades wise, we're looking at expand to remove denominator on both sides, giving line 3. So line 3 is up to here. This is going to be achieved. Line 4 can get you a merit, which is going to be, for us, it's going to be here. And then value of k found is excellence. All right, so next question. All right, so with this question, what we've got is, what do we got? We got two circles inside a rectangle. Now look, I'm going to slightly draw this diagram differently. Basically what I'm going to do is I'm going to do this. Okay, you get the idea. Basically it's those two half circles that are joined together to create two circles. Now it says find an expression in terms of x for the area of circle in the middle of the logo. So if this entire thing is worth x, then the diameter is going to be x over 2. That means the radius of the circle is going to be x over 4. So if the radius is going to be x over 4 and the area is pi squared, we're going to get pi times x over 4 squared. We're going to get pi x squared over 16. And basically, folks, this question is worth an achieved for this part anyway. Okay, so now looking at the next part of the question, it says the green, so here we go. If the green background has an area of 10, find the length of the rectangle. So the green part of this is all of this here. That's equal to 10. Now, what we can do is, sorry, I'm just going to work here. So we got these two circles, right? And the green part is all of this part here. The green part is equal to 10. So basically, to find out the area of the green part, we need to go the rectangle minus 2 times circle equals green area, which equals to 10. Now the height of the rectangle, well, the length of the rectangle is x, so that's easy. But the height of the rectangle is actually, well, actually, I'm just trying to think. We can even do it a quicker way than this, I just realized. Now let's do it the old school way, all right? So basically, if the diameter of the circle is going to be x over 2, then the height of the circle, which is the same as the diameter, is going to be x over 2. So this is going to be x over 2. So we've got area of a rectangle, which is base times height, minus 2 times area of circle. Now in the previous one, we worked out area of a circle, which was pi x squared over 16. So I'm going to put that here, pi x squared over 16. All of this is equal to 10. Now as for the base times height, that's going to be x times x over 2 minus 2 pi x squared over 16 equals 10. So x squared over, so this is going to become x squared over 2 minus 2 pi x squared over 16 equals to 10. And from here, I am going to start kind of simplifying things a little bit. Because it's x squared, I'm going to write that as 8x squared. Can I do 8x squared? Just want to double check. Yeah, let's try 8x squared. 8x squared over 16 minus 2 pi x squared over 16 equals to 10. Then I'm going to get 8x squared minus 2 pi x squared equals, well, all of that is over 16 equals 10. 8x squared minus 2 pi x squared equals 16 times 10. Then I'm going to take x squared as a common factor, so I'm going to get 8 minus 2 pi equals 160, and then x squared equals 160 divided by 8 minus 2 pi. So I'm going to get x equals to, I have a feeling I've done something wrong here. That's fine. I just got to trust the process and just see what happens. All right, so I'm going to go 160, and then I'm going to divide that by 8 minus 2 pi. Minus 2 pi. Okay, so that's going to give me x squared as 93.19, and then x is going to be square root of that, which gives me 9.65. Okay, now I'm actually on the, not bad. I was a bit worried there because the answer schedule had a different way they were doing it. They were actually figuring out what the r value is, and then they were trying to work out what the x was. So that's all right. So a couple of ways of doing this, but basically we've got achieved. Oh, there's no achieved because we got achieved from the previous question. Merit is correct expression for green area in terms of x or things. So green area in terms of either x or not, or r, not both. So I probably would say go here for a merit. And then excellence is correct value for the length of the rectangle. Now be careful. If you do work with the radius, then what happens is you've actually got to recalculate x. So don't just stop after you find the radius for this particular question. Cool, that's question 2 done. All right, folks, on to question 3. So basically what we've got is solve for x, log 5,625. Okay, so basically to do this question, you can just put this straight in the calculator if you want, because in the calculator, let me just find out. I think it's in the main menu. There we go, log AB. So in the main menu, just click on math, click on log AB, and then just punch in the values. So 5 and 625. There we go, x equals to 4. The other way of doing this is actually doing this as 5 to the power of x equals 625, and then taking logs of both sides again, pretty much same thing. For this question, can you just give correct answer? Yes, you can, and that's just going to be an achieved, and we move on to the next question. All right, so question 3b, what we've got is we've got 9 to the power of 2x plus 3. Now 1 over 27, now just remember that 27 is actually 1 over 3 to the power of 3, and this is x. Now 9, I can replace 9 with 3 squared. So basically, when I rewrite this, I'm going to get 3 to the power of 2 multiplied by 2x plus 3. Because remember, when you do powers of powers, you multiply the powers. As for the right-hand side, I'm going to bring the 3 cubed to the numerator. And when I do that, I'm going to get 3 to the power of minus 3. And that's to the power of x. So basically, I've got 3 to the power of, I'm going to expand the brackets, 4x plus 6 equals 3 to the power of minus 3 times x minus 3x. So now because I've got both sides where 3 is the base, I can get rid of it and just rewrite this as 4x plus 6 equals minus 3x. Then rearranging things, I'm going to get 4x plus 3x plus 6 is equal to 0. So I've got 7x plus 6 equals to 0. Then 7x is equal to minus 6. And then x is equal to negative 6 over 7. Grades wise, we're looking at rewrites at least one term as a power base with 3. So your achieved could be either here or here. And then merit is solving it correctly. All right, question C. So question C, we've got a bit of a substitution dilemma here. Basically, if you look at the first question, the log bx equals to 2, we can write this as b squared is equal to x. And then for the second one, we can write that as 3b squared equals to y. Now all it's asking is write y in terms of x. So what I'm going to do is I'm going to write y is equal to 9. So because it's 3b times 3b, I'm going to get y is equal to 9b squared, and then y is equal to 9x. Yeah, it's probably one of the easiest merit questions I've seen in a very long time. So rewrite at least one of the log terms in exponential form as an achieved. So either doing this or this is going to get you an achieved, and then at the end you're going to get a merit for this part of this question. I don't think I've ever actually gone through algebra paper this quickly before. But anyway, question D. Consider this equation where k is a constant. Use the quadratic formula. Okay, so we do have to use the quadratic formula where our a value is 3, b value is minus 4k, and c value is k squared. So we've got a equals to 3, b equals minus 4k, c equals k squared. So using the quadratic formula, so it's going to be minus b plus or minus b squared minus 4ac over 2a. So negative b means we're going to get negative 4k plus or minus b squared is negative 4k squared minus 4 times 3 times k squared divided by 2 times 3. So we've got 4k plus or minus square root of negative 4 squared is going to be 16k squared minus 12k squared divided by 6. So we've got 4k plus or minus 4k squared divided by 6, and we're just going to keep going. So square root of 4k squared is going to be, let me just do this part here first. So 4k plus or minus 2k over 6. So our first answer is going to be 4k plus 2k over 6. And our second answer is going to be 4k minus 2k over 6. So we're going to get 6k over 6, which equals to k. or we're going to get 2k over 6, and we're going to get k over 3. And folks, that's pretty much it for this question. So we've got our two little answers here. So for achieved, substitute the quadratic formula and evaluates the b squared term. Okay, that's interesting. I guess we're getting an achieved here, and then merit is getting our both of the solutions to get a merit. All right, so last question. Okay, so PO is the weakest sound human can hear. Cooling fan has decibel of 38. Okay, so let's go C. We're gonna go cooling fan is gonna be C, which is 38. And then heat pump, I'm gonna go with H, which is gonna be 30. So basically what it says is that the intensity of the sound and the weakest sound that human hear can hear. Okay, so the decibel level is going to be, what is it? We've got for cooling fan. I'm just going to do the cooling fan first, right? So the decibel level is 38. So that means we're going to get 38, 10 log 10. Now, whatever the intensity of the cooling fan sound is, over P naught, which is the sound the human ear can hear. And I'm going to do the same for the heat pump as well. So we're going to get 30 equals 10 log 10 PC over P naught. Not PC, sorry, PH. Because now this is the intensity of the sound for the heat pump. Now again, what we've got here is that the question is actually asking that show that the cooling fan sound intensity is more than 6 times. So we want to try and get PC by itself and PH by itself, ideally, right? That's what we want to do. Now we know that we could use the log rules. So I'm going to do 38 divided by 10. And when I do that, so I'm just going to do this, 38 divided by 10, and that's going to equal log 10 PC over P naught. So this is going to be 3.8 equals log 10 PC over P naught. And I'm going to do the same thing on this side for the heat pump. So I'm going to do 30 divided by 10, and that's equal to log 10, the intensity of the heat pump, over P naught. So then I'm going to get 3 is equal to log 10 pH over P naught. All right, now we're going to have to use the log rules. So if we use the log rules, what happens is that this will become 10 to the power of 3.8 equals PC over P naught, because that's the log rules, remember? And likewise on the other side, we're going to get 10 cubed equals pH over P naught. So we wanted to actually do PC divided by pH and see if it's actually more than 6. But we've got PC as PO times 10 to the power of 3.8. And then on this side, we're going to get pH equals P naught times 10 to the power of 3. So once we get this, we're going to put down the intensity for the cooling fan divided by the intensity of the heat pump. So for the cooling fan, we're going to get 3.8 P naught times 10.38 divided by P naught 10 to the power of 3. So what's happening here is the P naughts cancel out, and all you're left over with is 10 to the power of 3.8 divided by 10 cubed. And we can just put this in the calculator. So 10 to the power of 3.8, and I would like to divide that by 10 to the power of 3. Now as you can see, I am getting a rate of 6.31, and since 6.31 is actually bigger than 6, we can say therefore intensity, or the sound intensity of a cooling fan is 6 times more than heat pump. So grades wise, intensity of the cooling fan in terms of PO, except, okay, so we want to do something like this, to get a merit. This is a E7, E8 question. 6.3 times more intense. So if you get up to here, potentially writing a statement, you could get an E7. Explicitly says it's 6 given in the question. Yeah, so this right up here should get you an E8. And that's question 3. All right, folks, I gotta say that's probably the shortest algebra exam paper I've done in a very long time. But look, if you do have any questions, or if I have made any mistakes, please drop it in the comment section below. Yeah, and now, as always, this was actually quite a unique paper because there were some tricky questions in there, but they were actually pretty nice questions to kind of get along with. Anyway, that's it. Oh, forgot. Yeah, when you do finish this, good luck for your exams.
Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course, subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.